The thing, as we mentioned in that last video with the substitution method, is that it's not always obvious how you can start making a substitution, and even if you can manipulate your way towards one, it might be more work than you really need to use. So a different method that we have, and to be clear, not the only other method, we're only going to see a couple in this class, but there are more than just these. When we get to 5.3, we're going to see a special shortcut for certain cases with a particular setup. But anyway, for this, we're talking about the addition method, in which our goal is to kind of use addition to cancel out one of the variables within our system, which is why when I learned this stuff, I learned it under the name elimination, but it is elimination via addition, so I can see why they changed it, maybe make it a bit more of a positive reference there. I'm not entirely sure. In any case, for this, what we're going to do is, as before, make sure that our system is set up correctly. For this, we want it in the general form ax plus by equals c. Then, we want to multiply either equation or both by appropriate non-zero numbers so that the sum of one pair of coefficients is 0, that is, they cancel. Then add the equations you get from step 2, where you should result in an equation in one variable, solve the equation in that one variable, and then like before, back substitute and check to make sure that this works. So like I said, this isn't the only way that we can approach these problems. There are other ways we can think about them, but these are the main ways we're going to see it. And for us, we're going to get one example here working with the addition, or if you prefer, elimination method. So for this, we want to use addition to solve the system 4x plus 5y equals 3 and 2x minus 3y equals 7. So the first step is kind of for free here. It's already in that general form we're looking for those lines, as it were. I talked about not liking the general form way back when. I still don't, but it's nice for this. This is basically the only context in which it's particularly useful, and even then it's not really that much better than the other systems. It's just, it's consistency. Anyway, here what we can do is look at the pieces that we have here and recognize that substitution's probably not our best bet, because we've got a 4, a 5, a 2, a 3, a 7, and another 3, which means there's not going to be a nice division in there to isolate a y or an x in either of those without having a bunch of fractions to chase around. Instead, we can see that if we multiplied our second equation by -2, we would end up having a -4x plus 6y equals -14. But in particular, the x coefficients would match up. So if we were to add the two equations that we have there, what we would end up with is killing those x terms and just being left with 11y equals -11, or y is equal to -1. And then from there we can plug this back into one of our equations to get back the value for x. I'm going to plug it into our original equation from the second set, or the second equation from the original set, excuse me. But technically speaking, you can put it in wherever you want into either of those to get the right thing. If you go further with this stuff, you'll see that you have tons of different ways to equivalently write this and to get your value x at the end. But here, I'm just going to plug that back in to that second guy down there, where I would get 2x minus 3 times -1 equals 7. And like I said, the choice here is completely arbitrary. Usually you're going to see in these cases that one might be better than the others to deal with in terms of plugging things in and solving out to get your value. It depends. Sometimes there's a clear-cut candidate. In this case, there isn't really one, so I just picked the one that has the least coefficients. Anyway, pulling these pieces together, we're going to end up with 2x plus 3 is equal to 7, and hopefully at this point in this class you're confident enough in your ability to solve a linear equation that you know for this we're saying x is equal to 2. And I'm going to leave it again so you guys to check that this is the valid solution set, but here it would again be the ordered pair, in this case 2, -1, making up our solutions. Well, solution singular, really. And from here, we're going to talk a little bit more about how these things can come together, how we can end up with various types of solutions. We've seen the most useful case, as it were, where we have a unique value, but that isn't always the case. We in particular have 3 things that can happen, and that's what we're going to look at next.